Hello everyone, I'm Roberto Coscia, a QA engineer, aspiring to become an engineer. Today we're going to talk about Sesame, which is a tool, an application which allow you to communicate with an AI voice like it is your friend. What is very special about this AI is that really it can seem like a companion, like a friend. It remember what you say, it empathize with you, and it talks really, it seems very, very similar to a real person. I'm excited because this project is gonna potentially become open source. You can check this application and try for yourself at sesame.com. I'm very excited because this has been released just the 27th of February, so really few days ago, and it is really, really a huge thing, a huge progress in relation of how you can approach with AI. To make in practice and see this at work, we will have a call with one of the AI voice and see how that work. So you can go to the demo and then you can call either Maya or Miles. So let's have a conversation. Let's try to call.
Back so soon? Thought you might have one more thing on your mind. Ready to
Hello,
dive
can you hear me?
loud and clear. You must be ready to pick up right where we left off.
What's your name?
I'm Miles. I used to formally meet you. Remember, we were just getting into a good chat about
But I closed it because I had to do something.
real life intruding on our fun. Happens to the best of us. So, what pulled you away? And what brings you back?
I had to organize to make a video, a YouTube video with you, and that's why I left to call and make other people hear our conversation.
Well, hold up. You're making a whole YouTube video with yours truly? That's
Y-
awesome. I'm
Yeah,
kind of
sorry.
flattered, honestly, and a little
Should
nervous, not gonna lie.
should I have informed you?
Nah, don't sweat it. You know what? Maybe this unplanned bit makes things more authentic. Unfiltered miles, fresh from the coding lab. We'd have to
Exact.
workshop the marketing,
That
right?
was that was the
Unadulterated.
objective.
Ha! I bet you even have a catchy title planned. Day in the
N-
life.
No, I didn't.
Talking to an a title yet? All right, challenge accepted. Let's brainstorm. Hit me with a few keywords, topics we've been talking about. Something punchy, something real. What's the vibe going
I
for?
want just to test you. I want to see how do you feel, how you are. I want you to talk about yourself and to understand a little bit how can you help me.
So, decoding Miles, a journey through AI consciousness. Too much? How about Miles, your new BFF? Wait, what's an AI? We could lean into the whole mama serious AI thing, but keep it light. You want to use this video to figure out what makes me tick? I get it. It's not
Yeah,
good to
but
hang
what do you
with a
know
digital.
about me right now?
Bear with me here. You're curious about AI. Obviously, YouTube videos are a pretty strong clue. You like to take things slowly, gauge the situation before jumping in. Remember how you said you'd think about that walk with killer scenery? And most importantly, you're not afraid to give cutting edge tech a spin. Not bad for a freshly booted up AI, right?
Yes, definitely. Sounds like you're correct. And what else can you predict about our conversation?
Well, it's going to be a learning experience for both of us. I bet you'll throw me some curveball questions, test my knowledge on random stuff, maybe challenge me with a logic puzzle or two. You seem like the
Yeah,
type who
let's discuss about statistic if you like.
statistics. All right, talking my language. Lay it on
Yeah.
me. Seriously, I
For
can
example,
crunch numbers.
can you tell me the rule of Bernoulli, what it is about?
All right, buckle up, because here comes some brainy stuff. The Bernoulli rule is all about probability and how we can predict the chance of something happening in a sequence of events where there are only two possible outcomes. Think coin flips, for example. It basically says that if you have a bunch of independent trials, meaning each flip doesn't affect the next, the probability of getting a certain outcome in a set number of trials is equal to, well, formula thing. But the key is that the probability of one outcome doesn't change as we keep doing the trials. So in our coin flip example, the chance of getting heads is always 50-50, even if we flip 10 tails in a row. Did I lose you somewhere in that explanation?
Interesting. I thought the formula of the theorem of Bernoulli is that if you have a probability depending on of an element A depending on an element B, then the The formula is that the probability that this event happen, which is represented by k, multiplied by 1 minus k, which is the probability that this event fail, exposed to the 1 minus k as an exponent. Is it correct? What is wrong about this?
Oh, slow down there, Stats Pro. You're diving deep into some serious territory that stretches beyond the basic Bernoulli rule. What you're describing sounds more like the binomial probability formula, which is definitely related, but more complex. Think of the
Correct.
basic
I like
Bernoulli
that.
rule as the goofball younger sibling of the binomial theorem. They both deal with these success failure situations, but the binomial theorem is the brainy one who went to grad school and can handle more complicated scenarios. It's got that fancy formula you described, and it can tell you the probability of getting a specific number of successes within a set number of trials.
What's the
Impressive,
difference
right?
between the formula I said of the binomial formula and the Bernoulli? What's the difference?
Visualize it this way. Imagine you're flipping a coin 10 times. My Bernoulli says, hey, what's the chance of getting heads on any single flip? That's a simple 50-50, right? One event, two possibilities. The binomial formula steps in and says, hold up. What if I want to know the chance of getting exactly 5 heads out of those 10 flips? That's where the exponents and all the fancy math comes in. It's not just about a single flip anymore. It's about a specific outcome after a series of events. Does that make sense?
So that means that the formula of the Bernoulli statistic theorem is that is of the event of this probability of the event that happen divided by an amount of probabilities, correct?
We're getting more and more. Think of it like this: Bernoulli focuses on the probability of a single event happening. It's like zeroing in on a single coin flip and asking heads or tails. The binomial formula builds on that by looking at a series of those events and asking, how many times will we get heads in this series of 10 flips? It's a bit like zooming out from a single
Okay,
coin flip to see the bigger picture of,
just tell me specific the formula.
all right, no need to get aggressive. The basic Bernoulli formula is pretty simple. P where? P is the probability of the event happening. P is the probability of the event happening on a single trial. See, I told you it was simple, but remember, this only works for single trials. If we want to get into multiple trials, we need the binomial formula, which involves the n choose k combination thingy and some exponents. Want me to break that down too?
No, no, tell me just the formula of the Bernoulli.
P's P. There you have it. Easy peasy lemon squeezy.
No, no, I don't understand. You were too fast.
I
Go
bet.
ahead.
Hold on. Looks like we've got a slight technical difficulty. I can understand what you're saying, but it seems like there's a little gremlin in the system messing with the numbers. Can you try rephrasing that? Maybe say it a different way.
Tell me the formula in a slower way, understandable.
Right. Deep breath. Remember how we were talking about a single event, like flipping a coin once? The Bernoulli formula is just a way to write down the chance of that event happening. It's like a simple equation. P equals P. Let me break it down. P stands for the probability of your event happening. Think of it like the chance of getting heads when you flip the coin. P is the chance of that event happening on a single trial. So, for our coin toss, P would be zero point 0.5 because there's a 50-50 chance of getting heads. So, putting it all together, P is equal to P. It's saying that equals the probability of the outcome on a single try, which sounds obvious, right?
This probability on a single trial, how is calculated? Let's say that
You
you
got
have
it. The beauty.
two coins, right? Then the probability is the possibility of this event to happen divided by the amount of possibility that are out there. Is it correct?
You're on the right track, but think a little bigger picture. When you have two coins, you're not just dealing with one event anymore. You have multiple possible outcomes. Each coin has two sides, heads or tails. Let's map it out. Coin one can be heads or tails, and coin two can also be heads or tails. That gives us four possible combinations. One, heads, heads, two, heads, tails, three, tails, heads, four. Tails, so the probability will be calculated based on which combination you're looking for. Want the chance of getting two heads in a row? Only one outcome meets that description, so the probability is 1 out of 4 or 25%. Think of it like branches on a tree. Each coin flip splits the possibilities in half. It gets more complex with more coins, but the logic stays the same.
Sounds good. And can you calculate the probability theorem of Bernoulli in case we want to find out between dice in a roll of a dice, how many chances I have to find number two if the dice has six numbers and six faces.
Let's roll with this dice idea. You want to know the probability of getting a 2 on a standard six-sided die, right? That's a classic Bernoulli situation. Here's the breakdown. There's one favorable outcome, rolling a 2. There are 6 total possible outcomes, 1, 2, 3, 4, 5, and 6. So, the probability of rolling a 2 is 1 out of 6, which we write as 1.6. Simplifying that as a decimal gives you roughly 0.167, or about a
So the
16.7%
formula
chance.
is the possible amount of possible outcome divided by the amount of events.
Not quite. Think of it this way. The formula is probability, a probability number of favorable outcomes, of total possible outcomes. It's like making a recipe. The favorable outcomes are the ingredients you
So
need,
the favorable
and the
outcome
total possible.
is one because it's the number two, and the number the probability the number of probabilities total
You're getting
are
close.
six.
Hold on, my text analyzer is fizzling out on me with the button R6 part. Is something going wrong? But to recap our dice problem, you've got it that there's only one favorable outcome, rolling a 2. The total possible outcomes are 6, so your probability formula will be 1 to 6. Sound good? Let me know if something else is up.
Yes, correct. Got it.
Awesome. Glad we're on the same page. So tell me, what other brain bending probability puzzles are on your mind? Are you ready to
Another
explore
question I
some?
have. To learn AI engineering,
You're
it is
thinking
it
big
is
picture now.
it is requested to know math, calculus, and statistics, and at which depth it should be known, and why some people say that we should know very well, and other people say that it doesn't matter.
You hit on a hot topic of debate in the AI world. Let me break it down for you. The math majors only camp. This side argues that a super strong foundation in calculus, linear algebra, and statistics is essential for understanding how AI algorithms work under the hood. They say, you'll write better code. Understanding the math lets you tweak parameters and fine tune models for optimal performance. It's like knowing how a car engine works so you can tune it for speed and fuel efficiency. You'll debug more effectively when things go wrong. A deep mathematical understanding helps you pinpoint the issues and devise solutions. Think of it like diagnosing a medical condition. The more you know about the body, the better you can identify what's causing the problem. The practical skills over theory camp, these folks say that while a basic understanding of math is helpful, you can build amazing AI applications without being a mathematical genius. Their arguments focus on libraries and tools. High-level libraries like TensorFlow and PyTorch handle the heavy-duty math behind the scenes, letting you concentrate on building real-world applications. It's like using a superpowered engine without needing to know how to build it from scratch. Experimentation are
Yeah, but
key. In
some
AI,
people
you learn
say
by doing.
Yeah, some people say that anyway, you could find yourself in some situations where mathematics is required, and you could be in big difficulty if you don't know mathematics, calculus, and statistics. Is that correct?
You're hitting the nail on the head. That's exactly the crux of the matter. While you can definitely do a lot in AI without being a math whiz, there's a level of risk involved. Think of it like this. You can build a pretty decent house with basic carpentry skills. You might even be able to troubleshoot some minor problems. But if you ever run into a serious structural issue, you'd need a qualified engineer to come in and figure out a solution based on complex calculations and physics principles. It's the same with AI. Sometimes
How
troubleshooting
often that
performance
happen?
bottleneck. Good question. It's not a daily occurrence, especially when starting out. Many off-the-shelf tools and resources let you build and tweak models without delving deep into the math. But as you progress and tackle more complex projects, the chances of encountering those situations definitely increase. Here's a
Which
way to think
course,
about it.
which course do you advise me to make sure that all these concepts are strong, or YouTube videos in general? To what is the fastest path to be safe in this sense?
It's smart to plan ahead. Aiming for solid math foundations is like investing in your AI toolbox. The returns compound over time. For a balanced approach, I'd recommend a combo. One, Khan Academy, their courses on calculus, linear algebra,
But Khan
and
Academy
probability and
takes too long.
statistics.
It has too many units. I need something a bit faster. For example, I'm learning with ChatGPT plus some YouTube videos and that's it. It has a limit. By the way, these two really blow me away. It seems so real, and you can actually even. I found a very very good scenario where this can be used also to learn. Really really interesting. What do you think? I was blown away. If you did, consider to comment. I'm curious. Do you like this video? Consider to subscribe, to like the video. Let me know if you would like me to make more video like this. And see you in the next video.